Good day, Dr. Lukman. We are from Group 4 Mind-Rich Innovators. I'm Xiaolin and I will start with the introduction part. This system document explains MindBuddy, a cloud-based and mobile-friendly mental health platform for higher education students. It includes anonymous peer support forums, real-time counseling, and AI mood trackings, all connected to university systems. MindBuddy helps with mental health awareness, but it is not meant for emergencies. This document also covers the system requirements, design, user interface, and testing to give a full overview of the platform.
Next is the specific requirements of our project. In our system, there are 4 persona. The first persona is high education student. The second persona is mental health professional. The third persona is administrator. And the fourth persona is faculty member. Next, for the system features, the first picture is the use case diagram for MindBuddy. The second picture is the description module and function for MindBuddy. And the third picture is the domain model of our system. Then this 3 picture is our state machine diagram for the system. The first picture is the state machine diagram for counseling section. The second picture is the state machine diagram for self-assessment. And the third is the state machine diagram for appointment.
Our project is developed over 10 sprints, with each sprint focusing on one core module of the MindBuddy system. Sprint 1 starts with user registration and login, which is essential for all user types. Then, we progress through modules like mood tracking, AI chatbot, peer support forum, and gamification. Each sprint is assigned to specific team members based on their strengths. In the final sprints, we focus on administrative tools, dashboard, and security. This sprint-based approach ensures organized incremental development and allows us to deliver key features step by step.
Now, I will explain one of the use cases, which is US002, Daily Mood Check-in and Journaling. According to the user story description, it stated that as a student, I want to log my daily mood and optionally write a journal so I can track my mental health being. And this is the sequence diagram of the use case. The alternate flow happens when the student skips the journal, so the system will save only the mood. While in the exception flow, if the data cannot be saved due to some network issues, an error will be shown and the student can retry to submit it again. And this is the sequence diagram of the use case. For activity diagram, the main flow starts when the student logs into MindBuddy. The system will prompt a daily mood check-in. They will select their mood, optionally write a journal and submit. The system saves the data and updates the mood history charts. If offline, it will save locally and will sync later.
Now I will explain use case 3, which is the multilingual support for diverse users. The user stated that as a high education student, I want to access the app in my native language so that I can better understand and engage with the mental health content. So this is the sequence diagram of the use case 3. In an alternative flow, if the user does not select a language, the default language will be English. For the acceptance criteria, the post-condition is the app displays content in the selected language. The precondition is app must support multiple languages and the user must be logged in or using a guest session. For the activity diagram of use case 3, the system starts with the user accesses the settings menu and selects language preferences. The system then presents a list of available languages. The user then selects their preferred language. The system will reload all UI content and learning materials in the selected language. The language preference is saved for future sessions.
This is the use case description, which is for Persona 2 Administrator. As an administrator, I want to view analytics on student engagement so that I can monitor the usage patterns and also identify the area for improvement. Here is the main flow of this use case. So in this activity diagram, I will only apply transition for the main flow. The first step, the administrator has to log into the account. And then the student engagement analytics will authenticate the administrator. And then once successful, the administrator is able to access the engagement analytics section. And then this will trigger the system to display a filter data such as time spent on modules. Next, the administrator applies filter. While for alternative flow, I will apply decision in this activity diagram. If no data matches the selected filters, so the system will display no data found. But if yes, the system will display filter data, and then this will let the administrator to click the option of downloads or share the reports. And then this will trigger the system to generate the report, and then this is the end of the use case. Here is the sequence diagram for main flow. It shows how the administrator interacts with user interface, engagement analytics controller, analytics database, and also report generator within the system. And here is the main flow too. This is the alternative flow in the sequence diagram, same as what I have mentioned in the activity diagram.
Now I'll be presenting about the next use case description about the next persona, which is the mental health professional. So for the user story description, as a mental health professional, I want to be able to deliver feedback through message-based counseling so that I can provide guidelines to the higher education students. This is the main flow as well as the activity diagram of the use case. So, firstly, the mental health professional will navigate to the chat section. Then, the mental health professional will search for the student's contact number, then draft the feedbacks for the students based on the student's mental health status. After that, the mental health professional will add the suitable digital mental health resource for the higher education students into the feedback draft. Finally, the mental health professional sends the feedback and suitable digital mental health resource to the higher education students through the system chat functionality. Now, we'll be talking about the alternative flow as well as the exception flow of the use case. So for the alternative flow of the use case, at any point, the mental health professional can save the feedback as a draft to complete later. As for the exception flow, the system will auto-save the draft in case of any system error. So, this is the sequence diagram for the main flow 1, where it interacts with the mental health professional, the home page, the chat controller, as well as the students, the feedback, as well as the digital mental health resource. As for this slide, this is the sequence diagram for the second main flow of the use case. As for this slide, this sequence diagram shows the alternate flow of the use case as mentioned during the activity diagram. So, in this slide, the sequence diagram shows the exception flow of the use case as mentioned at the activity diagram earlier.
Next, I will be presenting about the use case description for Persona 4, which is faculty member. As a faculty member, I want to check record of the training module so that faculty member can monitor the status of mental health for the student. This activity diagram shows the flow of events. First, that the faculty member navigates to the training resource section. This will trigger the system to load available training modules. Next, the system will show available training modules. Next, the system will also prompt the user to select available training modules. By this time, the faculty member is able to select the available training modules. Once successful, the system will load the student records. And then this is the end of the use case. This is the main flow in this sequence diagram. It shows how the faculty member interact with homepage, training resource page, training modules controller, training modules database, and also notification service within a system. While for exception flow, I would like to highlight if the training resource fails to load due to connectivity issues or system downtime, the faculty member will receive an error notification.
So now I'll be presenting of the performance and the other requirements of the MindBuddy. So for the performance and the other requirements of the MindBuddy, it consists of 3 main parts, which are the response time, availability, as well as the reliability and maintainability. So for the response time of the MindBuddy, the system shall respond to users' actions such as page load and sending of messages within 2 seconds under normal load conditions. Other than that, message-based counseling feedback shall be delivered with a latency of no more than 1 second after sending. As for the availability of the system shall be available 99.9% of the time excluding planned maintenance. Furthermore, the downtime of the maintenance shall be scheduled during low usage periods such as late night hours. As for the last requirement, which is the reliability and maintainability, the system shall automatically save message drafts to prevent data loss during unexpected disruptions. Furthermore, the system shall have mechanisms for automatic recovery after crashes or outages. Other than that, data backups shall be performed daily and retained for at least 20 days. Now, let's move on to the next part.
For design constraints, MindBuddy needs to work offline, support low-end Android, secures data with encryptions, runs on major browsers, integrates with university systems, and it needs to handle 500 users at the same time.